Welcome to Eureka Tempus. In today's episode of Introduction to Physics, we'll be looking at units and measurements. Do not forget to like the video, and if you are visiting for the first time, subscribe to our channel and hit the notification bell so that you'll be notified when subsequent videos are uploaded. There are prerequisite videos that you have to see before this. If you haven't seen them, you can check them out in the description below. At the end of this lesson, students should be able to define a standard unit, list three properties of standard unit, and define measurement. Now let's discuss the concept of measurement. Whenever we measure something, we are essentially trying to find out how much of that thing exists, whether it's how long, how heavy, how fast, or how hot something is. Measurement gives us a precise way to answer that question. For instance, if I ask how much distance is there from one end of a table to the other, you might measure the length of the table and find that it is 2 meters long. Here, 2 meters is your answer to how much length. Again, if I ask, how much does your phone weigh? You can place the phone on the scale and see that it weighs maybe 2 kilograms. 2 kilograms answers the question of how much mass. Lastly, if I ask, how much time does it take to walk to your school? You might use a stopwatch and find that it takes 15 minutes. Yeah, 15 minutes is your answer to how much time. So in physics, when we ask how much, we are asking about a physical quantity like length, mass, time, or temperature. The process of measurement gives us the numerical value that tells us how much of that quantity we have. This helps us describe and analyze everything from the speed of a car to the brightness of a star. Measurement is all about finding how much of something there is. It is a way of quantifying everything around us. Now that we understand measurement as the process of answering how much, let's talk about how we can actually do it. To measure something accurately and consistently, we need a common reference. This is where the concept of standard unit comes in. Before we discuss standard unit, let's talk about what necessitated the establishment of standard unit, which is known today as SI unit. Imagine you are on a soccer field and you want to measure the goalpost. You don't have a measuring tape, so you decide to use your feet. You start at one end of the goalpost and walk to the other end, counting how many of your feet it takes to cover the distance. Let's say it took 12 steps. You tell your friend, the goalpost is 12 feet wide. Now imagine your friend tries the same thing, but his feet are smaller than yours. When he walked the same distance, it took him 15 steps. He said no, the goalpost is 15 feet wide. Here is the issue. Both of you measured the same goalpost, but you got different results because your feet are different sizes. This makes it hard to know exactly how wide the goalpost really is. If everyone used their own feet to measure things, we would always get different answers, leading to confusion. To solve this problem, we need a standard unit, a unit of measurement that everyone agrees on and that is the same no matter who is doing the measuring. Instead of using your feet or your friend's feet, you could use a standard unit like meter. By using a standard unit like the meter, we eliminate the confusion that comes from using different sized feet or any inconsistent measure. A meter is the same length everywhere. So when you say the goalpost is 10 meters wide, everyone knows exactly how wide it is. Let's explore why having a unified system of measurement, like the International System of Units, known as the SI unit, is so important. To understand this, it is helpful to look back at how different measurement systems were used historically and how they led to the development of the SI units. In the past, different countries had their own systems of measurement. For example, the British used the FPS system, which stands for foot, pound, second. This meant they measure length in feet, mass in pounds, and time in seconds. While the French used the CGS system, which stands for centimeter, gram, and second, where length was measured in centimeters, mass in grams, and time in seconds. While these systems worked fine within their own regions, They created challenges when people from different countries needed to share information or work together. Imagine you're a scientist in Britain trying to compare your research with a colleague in France. You have measured a distance in feet while your colleague has used centimeters. Converting between these units can be tricky, and any mistake in conversion could lead to confusion or incorrect conclusions. This problem wasn't limited to science alone, it also affected businesses, trade, and aviation. In the world of business, different measurement systems could cause problems in trade and manufacturing. For example, if a company in Britain designs a product using the FPS system and a company in France manufactures it using the CGS system, discrepancies in measurement could lead to faulty products or financial losses. Similarly, in aviation, where precision is crucial, using different measurement systems could lead to dangerous mistakes. Accurate calculations for distances, speeds, and fuel consumption are essential for safety, and inconsistencies could put lives at risk. To address these challenges, the global science community recognized the need for a single consistent system of measurement, and they came together and established what is known today as SI units. Therefore, we can define a standard unit as an agreed upon quantity that is used as a reference to measure other quantities. It is a benchmark that everyone agrees on, so when we measure something, everyone knows exactly what we mean. We have three properties of a standard unit. Number one is that the standard unit must be common in size. Number two, invariable with time. And number three, possible to reproduce. Now let's give critical examples on these three. Let's start with the first one, common size. It is a proven fact that different regions of the world use different containers to measure items like rice, garri, and beans. For example, in northern Nigeria, they make use of mudu. In eastern Nigeria, they make use of penta, and in western Nigeria, they make use of Eureka. Each of these containers holds a different amount, even though they are all used to measure the same types of things. Imagine you want to buy 10 units of rice, but you are shopping in different regions. In the north, you asked for 10 mudus of rice. In the east, you asked for 10 pentas of rice. And in the west, you asked for 10 dericas of rice. Even though you asked for the same number of units, which is 10, you will end up with different amounts of rice because a mudu, a penta, and a derica are not the same size. This creates a problem. If you try to compare or trade rice across these regions, it becomes confusing because there is no consistency in the amount being measured. You might get more rice in one region and less in another, even though the numbers seem to be the same. To solve this confusion, imagine if everyone in Nigeria agreed to use a standard unit for measuring rice, garri, beans, and other items. Let's say the kilogram. A kilogram is the same everywhere, whether you are in the north, east, or west. Now, if you ask for 10 kilograms of rice in any region, you will get exactly the same amount, no matter where you are. There is no variation based on the size of the mudu, penta, or derica used in this case. Using a standard unit like the kilogram makes trade fair and clear. It ensures that when you buy or sell something, everyone understands exactly how much is being measured, no matter where they are. Number two is that a standard unit must be invariable with time. This simply means that a standard unit is not supposed to change with time. That is to say, 1 meter today should be 1 meter tomorrow. 2 kilograms today should be 2 kilograms tomorrow. It does not change with time. Standard units were established in the year 1960, and this year makes it 64 years. For 64 years, nothing has changed, and nothing will change. So that is to say, it is invariable with time. And thirdly, it should be possible to reproduce a standard unit. For instance, imagine you and a friend are planning to build something together, but you are in different parts of the world. You both agree to measure things in meters. Now, for this to work, you need to be absolutely sure that when you measure 1 meter in your location and your friend does the same in his location, You are both measuring the same thing. This is where the idea of possible to reproduce comes into play for a standard unit. Like the meter, needs to be defined in such a way that anyone, anywhere can reproduce it accurately. This ensures that measurements are consistent across different times and places. Another example, let's say you are in Lagos and your tailor is in Abuja. You want him to sew a dress for you, but you are not there to give him the measurements in person. So you tell him your measurements in centimeters. For this to work, both of you need to be sure that centimeter you are talking about in Lagos is exactly the same as the centimeter is using in Abuja. This is why the property possible to reproduce is so important for standard units. It means that no matter where your tailor is, he can reproduce the same centimeter you measured with. This way, the dress will fit perfectly when you finally try it on, because the both of you were working with the same reproducible units of measurements. Having known what standard unit is, what then is measurement? Imagine you go to the market to buy some grains of rice. If the standard of measurement in your region is by mudu, that means you and the seller have agreed to use the mudu as a standard. Assuming you needed 10 mudus of rice, you are simply asking the seller to sell to you 10 times the amount of rice that fits into one mudu. Hence the counting 1, 2, 3, 4, 5, 6, 7 up to 10. The process of counting that standard 10 times is called measurements. Imagine in a football field, the players agree that your foot should be used as a standard to measure the goalpost of the opposing sides. Then you begin to count with your feet 1, 2, 3, 4, 5 until a particular number is reached. This is measurement in terms of multiples of the standard unit, which in this case is your foot. Therefore, measurement is defined as the process of determining the measurement of something by expressing it as a multiple of a standard unit. In conclusion, a standard unit is an agreed upon quantity that we use as a reference to measure other quantities. Properties of standard units include common size, invariability with time, and possibility to reproduce. And measurement is the process of determining the quantity of something by expressing it as a multiple of a standard unit. In our next class, we will be talking about fundamental and derived units. We will look critically at the calculations, derivations, and how the formulas of a derived unit can be established. Thank you for listening.